Welcome to Section 11, Lesson 1. Section 11 is dedicated to quadratic equations and their graphs, the parabolas. Quadratics are the next most important polynomial after linear equations, and they appear in physics, engineering, finance, and everywhere a value depends on a squared input. The standard form is y equals a times x squared plus b times x plus c, where a is non-zero. The constant that controls how wide and which way the parabola opens. B shifts the vertex horizontally and C shifts it vertically. The three constants together determine every feature of the curve. The parabola opens upward when A is positive and downward when A is negative. The vertex is the lowest point of an upward parabola or the highest point of a downward one. The axis of symmetry is a vertical line through the vertex. Three features completely describe a parabola: its roots, its vertex, and the direction it opens. Today's lesson introduces all three and shows how they connect to the standard form coefficients a, b, and c. Take y equals x squared minus 2x minus 3. Plotted on the right, the parabola opens upward, crosses the x-axis at 2 points, and dips to a low point in between. Match the equation to standard form. A is 1, b is negative 2, c is negative 3. Find the roots by factoring or by formula. X squared minus 2s minus 3 factors as x minus 3 times x plus 1. Setting each factor to 0 gives x equals 3 and x equals negative 1. Two real roots. Find the vertex. The x-coordinate of the vertex is negative b over 2a, which equals 1 in this case. Substitute back to find the y-coordinate. The axis of symmetry is the vertical line x equals 1, halfway between the two roots. Y equals x squared plus 4x plus 3. The parabola will have a positive leading coefficient, so it opens upward. Identify a BC is 1, B is 4, C is 3. Factor x squared plus 4x plus 3 equals x plus 1 times x plus 3. The roots are x equals negative 1 and x equals negative 3. The vertex sits at x equals negative 2, halfway between the roots. Substituting gives y equals negative 1. Vertex at the point negative 2, negative 1. Since a is positive, this vertex is the minimum value of the parabola. Example 2. Y equals negative 2x squared plus 8x minus 6. The negative leading coefficient means the parabola opens downward. Factor out the negative 2. The expression becomes negative 2 times x squared minus 4x plus 3. The trinomial inside factors as x minus 1 times x minus 3. The roots are x equals 1 and x equals 3, the same x values where the trinomial equals 0. The negative 2 out front does not move the roots, it just flips the parabola. The vertex sits at x equals 2, halfway between the roots. Substituting gives y equals 2. Vertex at the point 2, 2. This is the maximum of the parabola since a is negative and the parabola opens downward. 3 takeaways for quadratic equations. They unlock every parabola problem in this section. Standard form is y equals a x squared plus bx plus c. The sign of a determines opening direction. Positive means up, negative means down. The magnitude of a control's width, large A, is narrow, small a is wide. The roots are the x values where y equals 0. Find them by factoring when possible or by the quadratic formula when factoring fails. Real valued roots correspond to x-axis crossings on the graph. The vertex's x-coordinate is negative b over 2a. The axis of symmetry is the vertical line through the vertex. Substituting the vertex's x back into the equation gives the vertex's y, completing the location of the parabola's lowest or highest point.